Okay, part two, autopilot inner workings. So in the last session, we went through all the scenarios, all the pieces. This time we want to get more into just random what's going on behind the scenes. Figured we'd start off with a little bit of a history lesson. If you go back to 2015, which is what, well over like 8.5 years ago, there was a JAMP conference that had a presentation from IBM, from Fletcher Previn, VP of Workplace as a Service at the time. Get where he works now. He's like CIO of Cisco or something like that. But they did a presentation saying Windows are awful, Mac OS is great. Look at how easy it is for us to deploy new Macs. And it caused a press firestorm, basically saying IBM, the inventor of a PC, is now saying we're not going to use PCs anymore, we're going to use Macs. So they're going to fast. Resulted in the creation of Autopilot, basically saying we're going to work with IBM care closely and try to do the same thing that they're doing with Macs or Windows devices as well. And what they did with JAMP required a whole lot of customized stuff, that they would build a UI, they would build a delivery mechanism, they built all of this stuff to push out the configuration to devices. Okay, we just need to recreate that in Windows. And kind of typical Microsoft style isn't to start from scratch, it's to try to piece together a bunch of existing technology and make it work with the minimum effort and time as required. So that's where you started to pull in things built around Windows activation and services that you wouldn't think of as being part of a provisioning solution, but they do actually work out pretty well. So no big surprise, the first big customer of Autopilot was IBM, because we were working to develop it with them to be able to say, it doesn't matter what kind of devices you want to deploy to your organization. If you're going to deploy a Mac, you're going to use Apple Dep, which has now got a different name, but it's Dep at the time. Or you're going to use Android Zero Touch, or you're going to use Windows Autopilot. But the idea overall was the same, that you're going to support provisioning devices where you take whatever shipped on them, layer your stuff on top of it, let the user do it themselves, not have to involve IT. That was the big goal. In 2015, when we started working with them to do that, it was actually building using, I think they were using BigFix at the time, and MDT task sequences downloaded from the cloud in an ISO and then executed with a nice UI front end that made it look pretty. It evolved from that to Autopilot in 2017, where that was built into the out-of-box experience. In 2018, and we started getting the enrollment status page and being able to track the progress and display when everything is done, because before that you had to build your own custom solutions to do that. Additional scenarios added over the years: hybrid Azure AD join, self-deploying, Windows Autopilot for existing devices, white glove, now called pre-provisioning. So all of that happened in 2017 to 2019, really to just build out the capabilities. I would like to think that the following years after that are a result of me leaving Microsoft, because 2020, not much happened. 2021, they added a diagnostics page, which was actually a feature that I was working on before I left. So unfortunately, I think it's a shadow of what it should be, but it at least should. And then they did some things in 2022 to handle the hash challenges with PC repairs. So there have been some changes. 2023, if we were to add that to the list, would be more of the same. There really wasn't a whole lot of change in 2023 related to Autopilot. Obviously, the Intune service behind this keeps getting additional enhancements and capabilities, but Autopilot itself is fairly static. I think that'll change in 2024. I think we'll start to see new features coming out for Autopilot as there are, if you've seen some of Rudy Boom's blogs, he's talked about Autopilot V2 and some of the stuff that's in the current Windows builds. It's not done yet, but it's in there and it's being tested, and you can see that there's work going on. So we might finally get to a point where we can put a 2024 bullet on here and say, yeah, they're finally making some enhancements to this. The earliest picture was basically to walk through the process where hardware vendor provides device IDs to an IT admin, or the IT admin harvests them themselves. You upload those into the Autopilot service. You configure a profile on those machines, and then you can ship the device directly to the employee for them to configure themselves. I've yet to find a customer actually doing direct shipments from OEM to end user. I know Dell and others will happily do that as part of custom logistics services, where you can send them a spreadsheet with the names and addresses of everyone you wanted these machines to go to, and they would happily register them with Autopilot, put a mailing label on each one of them, and ship them to the end user. They'd be set to go. They'll even put instructions in the box for you if you want. So all of that's possible, but still it tends to be too much of an IT-driven process. But we'll eventually get there. The stages, as we go through it, if we look at the Autopilot pieces overall, there's pre-deployment stuff, and then there's deployment stuff. The pre-deployment stuff are really things done by the OEM at manufacturing time, as well as things that OEMs or resellers could do, or the IT person could do to prepare for the deployment. At deployment time, we've looked at most of that, where the device discovers what it needs to do, it downloads the profile, it joins AAD, and it rolls it into. So all of that's probably a little bit more straightforward, but some of these are a little bit more interesting. On the pre-deployment side, when an OEM puts a Windows image on the device, they have to inject a product key into the firmware. So every device that ships with Windows ships with an embedded product key. That product key, when it's generated and put onto the device, the OEM will create a computer build report. That computer build report is an XML file that contains a whole bunch of information about the device, including the hardware hash that Autopilot uses, which is 4,000 bytes now, but when this was initially put together, it was only like 128. So it grew significantly, coincidentally, around the same time that Autopilot was being created. But OEMs, for every device they manufacture, they send that computer build report to Microsoft, containing the hardware hash, containing all the details about the device. So there's some giant database inside of Microsoft that has the details of every machine manufactured since 2016. When OEM or reseller registers the device, they register it with a serial number. Serial number is used to look up in a database the computer build report to find the hardware hash for that device, because Autopilot still requires that hardware hash in order to do the registration. But it just means that all of this stuff that Autopilot is using around device registration and hardware hashes and all that good stuff has been around as part of the OEM activation process going back to the Windows 7 days. So nothing much new about it. It's just been piggybacked for additional uses for Autopilot. If you look at a hardware hash, most people would think a hash is a hash. I mean, it's a whole bunch of things that get processed in some way, and it creates a string or a number or something that you can't reverse to get back to the original data. Well, that's not the case at all, because these hashes aren't really hashes. They're really just a binary conglomeration of data about the device. It's then base 64 encoded into a 4,000 byte string. Now, the data that's being encoded isn't 4,000 bytes long. So if you look at a hardware hash and it ends with a whole bunch of A's, guess what those A's are? They're binary zeros. So it's probably 1,500 to 2,000 bytes. It is somewhat variable because it includes details about network cards, video adapters, hard drives, and all kinds of stuff about the device, which can vary. One of them, five of them. So all of that gets encoded into that hardware hash, but it basically means that you can decode these and see exactly what's in them. So I did publish some PowerShell scripts that will take the hardware hash, base64 decode it, and then pull out the individual fields. As the basic structure then is a 1 byte identifier field that says what this is. Is it a MAC address? Is it a serial number? Is it an asset tag, a manufacturer, a model? All of that is in there. And then the data itself follows it. So you just need to understand type values and then the data type of the whatever it's after. So you can run a PowerShell script, feed it a hash, feed it a CSV file, and it dumps a whole bunch of information about the device. That's everything that's used in some way to identify the device to Autopilot. But if you were to actually dig in and look at the registration process, you'll see that it's not actually using all the pieces of that. So if you register a device through the OEM, they use a serial number, or a partner, they use a serial number, they register with that, it finds the hardware hash and can use that hash. But then it will take pieces out of that hash. There's like 6 or 7 pieces that it pulls out, and it will use that to talk to the MSA service. MSA, Microsoft Account, is the service that will take hardware attributes and use it to generate a unique ID. If you remember back to, Windows XP, there was a feature added called Windows Genuine Advantage, that if it was a legitimate machine, you would see in the Windows Update control panel, this is a genuine Windows PC. How does that work? Well, that just meant Windows took that hardware hash, really 6 or 7 pieces out of it, sent it off to this MSA service, and got back, if it was a valid, licensed, good machine, it would get back that unique ID that says, yep, okay, I know what this is, and therefore it is a valid machine. It is a valid license. So again, we're piggybacking on top of existing things. In this case, that Windows Genuine Advantage setup that can take a certain number of attributes from the machine and use that to generate a unique ID. So once the device is registered with Autopilot, it really doesn't need the hardware hash anymore. In fact, it doesn't even store the hardware hash. It takes the hash, pulls the fields that it wants out of it, passes those off to the MSA service, and it gets back a globally unique ID. That identifies the machine. So everything in Autopilot is tied to that ID instead of the hardware hash. So then when a machine boots up, the machine will go through the same process. It will take that same list of attributes, send it off to the MSA service, and get back a global ID. So now the machine can ask the Autopilot service, hey, I've got this global ID. Do you have any profile for me? And it'll get sent down from the Autopilot service. The challenge that you can run into is that a device, the hardware hash attributes that are used are mostly related to the motherboard of the device that's being used. So if you have a PC that you buy from Dell, as an example, and there's an issue that causes the motherboard to fail, you send it back to Dell, they repair it, they send it back to you. Their repair process generally swaps out the motherboard for another one. So PC comes back, it has a different motherboard. As a result, it's going to have a different unique ID because the hardware hash has changed because all the attributes have changed. So it becomes effectively a new device as far as Autopilot is concerned. That's not too bad. You just have to recognize that when you get a device back for repair, you might need to re-register it. But think about what happens to that broken motherboard. Dell might look at it and say, oh, hey, we can fix this. The problem that we see is repairable. Let's fix that motherboard and put it back onto the pile so that when the next device comes in for repair, they pull it off of the pile and put it into that device and ship it back to whatever customer this new device came from. So now you have that old Autopilot registration information getting sent to a different customer, and that customer boots up the machine and wonders, why the heck is this going through Autopilot for a different company? So you've got weird scenarios like that, as well as companies that order PCs and then realize, oh, hey, we ordered too many of them. Now we want to return some, but they don't deregister them before they send them back. So you start running into all these weird scenarios where one customer gets a computer that's registered to another customer. It's fixable. You can open a support case with Microsoft, provide them with proof that you actually own those PCs, like an invoice from the OEM that you bought them from, and they'll deregister the device manually from the one tenant so that you can register it first. So you can fix up most of those, but the goal is to try to fix as many of these as possible through an automated mechanism. So if you have a device that you send off for repair, it comes back with a new motherboard, but the existing hard drive is still intact, so it still had a functioning OS on it, you're going to get that device back. It's still joined to Azure AD. It's still enrolled in Intune. It's still functional, but it's no longer registered with Autopilot. So if you reset it, it wouldn't go back through the Autopilot process. So this fix pending state was intended to be able to detect that something's changed. We know this device got into the system because it was registered with Autopilot, but now the details don't match. So Intune will be able to detect this, grab the new hardware hash, register it with the service, and fix this. That works great in that one scenario. It works horribly if you're using virtual machine snapshots. Because imagine you have a machine, like I'll create a new virtual machine and I'll create a checkpoint either before the machine's been turned on or if you started looking, depending on what moved in that day. So that I'll go through an Autopilot deployment, and when it's done, I'll reset back to that checkpoint and then go through the process again. Works great the first time. Second time, it behaves like it's no longer registered with Autopilot, and I'll go in and see that it's now in a fixed pending state. Crap. It's not ever going to be able to fix itself because the only OS that could fix it is the one that I just reverted by going back to a previous checkpoint. I don't have that OS to let Intune fix it. So the only way to fix that is deregister the device, re-register it. But if I can checkpoint the machine with this new Autopilot marker, which is basically a UEFI attribute that's placed into the firmware of the device, if I can capture the machine in that state, now reverting back won't cause any loss of that Autopilot marker, which is a GUID value, and it won't have to repair itself. So Rudy had posted a blog on that. I posted another one that basically says, here's how to create a VM and how to get it into a state where you can reset, try again, reset, try again, reset, try again. Just by making sure you capture it with the Autopilot marker in place, knowing that that marker is never going to change as long as you never migrate that VM to another IPOs. So you will start to see some interesting things with that. You can also run into challenges if you deploy different versions of Windows because some older versions don't have this logic, some newer versions do. So you could run into a case where you deploy different OS releases and also get it into these fixed pending states. So the intent is good. The intent is to try to fix problems where devices aren't registered properly, but there are some ways that you can easily shoot yourself in the foot by going through that. Profile assignment. We talked about this in the other session. We don't need to deal with too much of the detail, but The behind the scenes process is you import a device to Intune using the hardware hash. Intune immediately pushes that to the Autopilot service. The Autopilot service goes through and talks to the MSA, gets the unique ID, and it's the registration process using that, and then throws the hardware hash away. Well, it all works properly. We then get requests from customers saying, hey, we want to move to a different tenant. Can I export those hardware hashes and move those over? No, because we haven't stored that hardware hash anywhere. It's just used to generate that globally unique ID. So if you run into interesting cases like that, where this profile assignment and the fact that it's only using those IDs behind the scenes can be particularly challenging. On the deployment side, the machine will boot up into UBI the first time. It will connect to the network, which could be wired or wireless, doesn't matter. It will register with MSA and get that unique ID. And then it will ask the Autopilot service, do you have a profile for me? If it does, it downloads that. It's a nice simple JSON file. If it doesn't, it gets an empty profile back, which is basically its way of knowing that this is not an Autopilot device. So based on that result, it behaves differently. If you see the EULA, if you see the security settings page, if you see any OEM registration page or anything like that, there was no Autopilot device. You can watch all of this via network trace and see all of this going on. So you'll see it talk to the login.live.com, the MSA service, passing a set of computer attributes, which look like gibberish. They're all base 64 encoded, so you can decode them and then try to figure out what is this thing. But it's basically the serial number and ASIN tag and hardware serial number, or the hard drive serial number, and some TPM details. So all of that's passed forward, and then it gets back a response that contains the unique ID. It can then turn around and talk to the DDS service for Autopilot, passing that unique ID, and it'll get back a profile. So in that profile, you can decode that and see the details in the resulting JSON. So the process itself is relatively straightforward. If you look at the machine itself, you can find that Autopilot profile written to C Windows Service State WMAN SVC as a folder under Windows called Autopilot ZTD or Autopilot DDS ZTD file.json. It has the date and time that profile was downloaded. It's only downloaded during UBI. It will be downloaded after each reboot. So if you want to get a new one, like you registered the device and it hadn't yet assigned a profile and didn't get one, and get this blank file, reboot the computer, you'll try again, and maybe the next time you get something that looks more like the bottom one. But you can take a look at that and be able to see the details. The ZTD registration ID is a unique ID assigned by the Autopilot service. But that's separate from that unique ID that we got from MSA. So there's all kinds of different IDs floating around in there. But we can see what kind of join are we going to do. In this case, 0 is AAD join. Some of these are flags. So this cloud assign UBI config 1310, we'd have to break that flag down into individual bits to be able to understand that. But this is the Autopilot profile. You can see all of those details just by pulling that file up. That file will remain, so it is a good way of seeing, was this an Autopilot deployed device that went through UBI that downloaded the profile? Now, that's not 100% a guarantee that it actually went through Autopilot for the enrollment, but it's usually a pretty good indication because this file wouldn't exist otherwise. If you want to decode that file, there is a script called get Autopilot diagnostics.ps1. There's now a new community version of that as well. The community version gets rid of the error that's up on the screen, which we probably can't see very well, but the community version fixes that and has a few other nice changes to it. So you might want to try that one out. But it can interpret that file and display tenant details. It can break down the bitmap so it knows that, okay, this 1310 value means we want to skip the keyboard. We want to skip the Windows upgrade UX. We want to skip the EULA, skip OEM registration screens, skip express settings, and disallow admin rights to the user that's signing in. That's a lot of settings. If you actually look at the Autopilot profile, several of those don't exist in the Autopilot profile because they're just hard coded. That you will always skip the Windows upgrade UX during UBI. What is the Windows upgrade UX? If you've ever manually gone through UBI on Windows 10 or Windows 11 and you're running an older release, it will come up with a message saying, hey, you're not running the most recent version of Windows. Would you like me to download and install the newer one? If you say yes, it'll kick off the download in the background. And then once you're signed in and at the desktop and that download completes, it'll pop up a notification saying, hey, your upgrade's ready now. Would you like to start? IT hates that. Odds are, if you're using an older version of Windows, you're using an older version on purpose. And if the user doesn't have admin rights anyway, they're not going to be able to initiate that upgrade themselves. So why would we ever want to show that UI for an IT managed machine? So that's what this bit says, is we never want to show that page in UBI. But you can see all the details. We'll interpret the scenario. We can generate some statistics, like from delivery optimization at the end of the process, knowing that Intune uses DO for all Win32 app downloads. We can see how many total bytes have been downloaded using delivery optimization during the Autopilot process. It's basically from the birth of the OS until the time you run this script. And then see how much of it came from peers and how much came from a connected cache server. In this case, on my screen, they're both zeros, meaning that every bit that needed to be downloaded had to come from the cloud. So in this case, that's not too bad. We look at the number, that's 46 megabytes worth of apps that needed to be downloaded. That could be significantly higher if you have a lot of apps or big apps. And if you're downloading a whole lot of data for these Win32 apps, you really want to get as much of that from peers as you can. So first client, sure, download it from the internet. Second client, grab it from that machine over there. Great, in corporate networks, you should be able to get that peering percentage up to something significantly higher than 0. It's never going to be 100. There's just too many variables in play to be able to get it to 100, but you should be able to get that into the 60s to be able to say that we don't need to get all this data from the internet every time we're deploying a device. It'll be much faster and much friendlier on our WAN connection, internet connection, to grab peers. There are some tricks to doing that to get delivery optimization configured properly to handle that. Big surprise, I work for Tupite. They build tools to do that. So definitely read through some of the blogs on the Tupite website that talk about DO and how all that works. The rest of it will display kind of like an event view of the Autopilot process. So you can see the time that the A80 join happened and the time of the Intune enrollment. Now we started to download the Intune management extensions. Then it installed, and then it detected what apps were needed. Then app 1 installed, then app 2, then app 3, then app 4. So it will give you that event view of really what was going on and when did it finish. So if you get a user who calls a week later and says, oh, this took forever, you can go back and look at it and say, it didn't really take forever. It took 30 minutes. 30 minutes on your crappy home Wi-Fi is probably not too bad. But 30 minutes on the corporate network where we normally see it take 5, all right, then something weird's going on. We should investigate. But it's that sort of data that you should be able to get out of the script. We talked about this before. A device doesn't have to be registered with Autopilot to use Autopilot. Autopilot for existing devices can read a JSON file. You don't have to do a wipe and load for that. As long as you drop the file into C window provision Autopilot and Autopilot configuration file.json, before it boots into Ubi, it'll use that and behave like an autopilot file. So all these people that deploy an OS and then register the device, wait for it to be registered, and then continue through the autopilot process could just drop that JSON file in place and reboot and achieve the same thing. Now, there are some downsides for that. The biggest downside is that device isn't going to be known to Intune. So as a result, it's not going to have an Azure AD object. So therefore, it's not going to be in any groups. So therefore, it's not going to get any policies or apps or anything else because brand new machine, it's not in any group, so it can't possibly get anything. Eventually, it probably will because dynamic groups will update and the policies will get evaluated and then everything will happen. But otherwise, it's only going to get things that target all devices or all users. So there are limitations with doing that, but otherwise it is a nice simple scenario. You could create a VM, a VHD template for a VM and inject that autopilot configuration file.json into it, knowing that every time you then boot that a new VM created off of that template, it's going to go through the autopilot process because of the existence of that JSON file without you needing to register it at all. So it's worth considering. It has some uses, but it also has some limitations. So once the profile is received, now Autopilot has to figure out what to do. So that what to do can involve Azure AD join, hybrid Azure AD join, or self-deploying. The existing devices we just talked about, pre-provisioning works with either of the user-driven scenarios, but that's basically to get everything put on the device. Everything starts off the same way. We need to authenticate with Azure AD. Even in the self-deploying case, we have to authenticate with Azure AD, but in the self-deploying case, we can do that with a machine token rather than a user token. So in Ubi, you type in your email address, really your UPN for your Azure AD account. That will effectively be used to authenticate once you put in your password and complete the MFA challenge. There is some odd logic going on. If you look in a network trace, you'll see it go through a disambiguation process, which is rather entertaining. If you remember back when Azure AD was initially created, you could specify your DNS Azure AD name, so like Toso.com, and it would create an Azure AD tenant with that DNS name. What if you had MSAs created on that domain before you created your Azure AD tenant? Now you've got a problem there. Is this user an MSA user or an AAD user? And in this case, the answer might be both. So initially there was a big mess of trying to figure out, I don't know if you're putting in an Azure AD account or an MSA because you could have both tied to the same email address. So this disambiguation page would basically have rules to say when you pass in an email address, it will come back with an MSA answer or an AAD answer. But if you think about that from an autopilot perspective, the answer is always AAD. If you've got an autopilot profile assigned to the machine, you don't want this machine to be joined to, or not really joined, but you don't want it to be using an MSA account. You always want it to use an AAD account. So it's silly to go through this disambiguation process, but that's the way Ubi works, and no one inside the Windows group wanted to fix Ubi. So yes, even today, it still goes through a disambiguation process that always has the same answer. Over time, Microsoft has fixed that problem by effectively saying you can't do this anymore. You can't create an MSA with a corporate email address. Once you create an AAD tenant with that particular DNS domain, your MSAs are no longer going to be valid. You'll have to change those MSAs over. But for years, that was a mess that unfortunately now isn't anymore. So you type in your UPN, your email address, and your password. They are sent, oddly, in clear text, not really, but they're inside of an SSL stream, so they are encrypted. And they're validated by the Azure AD service, and the user token is passed back. So user token, if you've ever looked inside of one, it's a big encoded base64 blob. If you break it apart, it becomes a JWT, Java Web Token. And that has details in it like your given name and your location, and there's a password reset link and the display name for your tenant, and all sorts of information contained in that JWT. But that contains the important pieces that are used to tell the machine what AAD tenant am I going to join. That part's obvious. But also it becomes the key piece to figure out what MDM service do I need to talk to, because the JWT will contain the URLs that you configured in AAD that tell it to talk to Intune. So this whole authentication process also has a side benefit of being able to say, here's your MDM service, please enroll with that, which is kind of nice. That causes another interesting twist in self-deploying. In self-deploying, there is no user, there's just a machine. So we can't ask AAD for the URLs for a machine. So the cheat that's used instead is interesting. It will ask for the URLs for a non-existent account. I don't remember what account it uses. I think it uses like Autopilot at domain name. So it asks for that, and it will get back the Intune URLs, but then throw away all the rest of the information. But it still gets the information that it needs, which are those discovery URLs that you need off of the Azure AD settings. If you look at the breakdown, you can see that it includes basic details. Name, that's my family name, my given name. So pretty much what you would expect from an identity service. I mentioned that terms of use webpage before. If you build a custom one, you got to build a sample that just takes all the inputs provided to it and displays them to the page, and then has an accept button that causes a redirect to the provided URL, which is the first parameter. So the page gets told, whenever you're done, post back to login.microsoft.online.com/webapp/cloud-domain-join/10. So it sends a request to that, and then that ends up redirecting back. There's a correlation ID, which doesn't really matter. There's the Azure AD join, the join type could be hybrid, could be Azure AD join. And then there's the user's bearer token. That bearer token has been constrained to access the Intune service for certain functions. How many, I guess, silly question. If you go back in time, Intune had the ability during enrollment to ask you for the device category. It can prompt you for the device category for the device, which is kind of handy as you're deploying a new iPhone or Android device or Windows PC. You could say this is a sales device, or this is a engineering device, or this is a developer device. Well, then Autopilot came along, and Autopilot had a self-deploying mode that was designed to deploy a machine with no user intervention. Guess what got in the way? A prompt for a device category. How did they fix that? They just turned off the prompt because they said, well, there aren't very many people using that anyway, so let's just turn it off. And then forget it ever existed. So you can't turn it back on now if you want to. The proper answer would have been, let's only show that when we're in a user-driven scenario, either without Autopilot or with Autopilot. If we're doing self-deploying or pre-provisioning, then we don't want to do that. We'll take the default, but otherwise we should continue to prompt. And sorry, you lost that feature. Maybe you'll never get it back again. So today, the only way of setting a device category is to go into the Intune portal and set it from there manually. There used to be a way for you to set it during GUI because it was a part of the terms of use page.
Company portal will force you to pick a device category.
Company portal will let you do it now after the fact.
Will let you. forces.
Forces you to.
Forces.
I haven't seen that, but then again, I don't use company portal routinely, but makes sense. I mean,
I wish there was a way to disable it. If you happen to know some magic backdoor, it's worth beer.
well, in theory, you could use that bearer token to talk to the Intune service to set it for the device. Exactly how you would do that is an exercise left to the reader. I've not tried to actually use that bearer token to talk to Intune, but in theory, that should be sufficient for you to talk to Intune and set the device category for the current device. I have to know what to set it to. If you're just going to hard code it, that's not a big deal.
Yeah, quick question, stupid question. So is it like device group and device category same that you're talking about, or?
No,
That's different.
device category is more like a tag on the device. You
Okay.
could use it for Intune policy assignment,
Yeah.
but it wasn't used anywhere outside of Intune. Whereas a device group is an Azure AD thing that you can use for all sorts of different things.
Okay, yeah, security groups comes from Azure AD, but there is something called device groups that you can use in Defender to categorize your devices. I'm just kind of trying to see it's the same that works with Intune or kind
All
of different,
Yeah.
or like Microsoft terminology that confuses people.
Yeah, and that's probably why they've been de-emphasizing it, because it is yet another way of grouping devices.
Yeah.
Like Autopilot had group tags, Intune had device categories. Everything had their different way of doing it. Now they're trying to consolidate around Azure AD groups for the most part, but yeah, this is something different than that.
Sure.
Not that anyone really cares, but this terms of use page is supposed to be called all the time for every Intune enrollment. For hybrid Azure AD join, it isn't, which is weird. It's a bug. I filed that with Windows years ago, and I don't think we'll ever fix it. But if you do ever try to use terms of use, know that it doesn't work in hybrid Azure. Let's skip some of that part. Build your own. There is an example published on docs.microsoft.com, which is now a lot of learn.microsoft.com. So the chance of that URL working is about 50-50 if they got the right redirects in place. But it provides a sample with a style sheet and HTML and show you how to implement it. But I've also got this sample one posted somewhere. Talked about this. If there isn't a user, you have to use TPM attestation in order to get an Azure AD authentication token. The enrollment settings are retrieved using a fake email address, but achieves the goal. And then it's joined to Azure AD and enrolled in Intune using that machine token. If you follow the flow, it seems overly complicated, and to a certain extent it is. The enrollment process, or really the whole MDM flow inside of Windows, came from Windows Phone. It was built with Windows Phone 8. It might have even been around Windows Phone 7, but pretty old. Built around an industry standard called OMA URI, OMA DM. No one else in the world uses that protocol. It is a Windows specific thing now. OMA DM is dead to everyone else. Apple uses something different. Android uses something different. Every other platform uses something different. But this is what Microsoft chose at the time, and it really hasn't changed since. You will take that discovery URL that's provided by Azure AD and make a request, and it will reply back with an XML blob, really a SOAP payload. Remember SOAP, that's how far back this goes. That will specify a whole bunch of other URLs that are used to continue the process. So you'll take the discovery URL and then talk to the enrollment URL and the policy URL and use all of that to complete the enrollment process. It's at least well documented. I built my own MDM server in Node.js just to prove that I could do it. And it's super messy, but any MDM vendor can probably figure that out. So once it's got the discovery information, it can make an enrollment request containing that AAB user token. That will also specify to say, I need a certificate for my device, because all the communication between the device and Intune is certificate-based, certificate authenticated. So it's not going to use your user token anymore to talk between the device and MDM. It's going to get a device cert and use that for authentication. And then the Intune and the MDM protocol handle automatic renewals of that certificate before it expires. So very secure, make sure that it's always using that for authentication. Included in the enrollment request, in addition to that device certificate request, which is a certificate template that the Intune service generates a certain board and returns it back, are also details about the user and the OS. I've got a blown out version of that. Yep. So we can see the details that are provided to the Intune service. So Intune knows that this is being initiated via GUI. Here's the hardware device ID. It's a locale of ENUS. Targeted user logged in. Yes. So that was false in that case. OS edition 4. If we look that up, OS edition 4 is enterprise. There's a different value for pro, so it can tell the difference between those two. Current computer name, the MAC address, the MSA device ID is included. Enrollment type, in this case, it's the device enrollment, so that would be a pretty much they're all nice enrollments. In this case, it is a Windows device trying to enroll. It has a version of 10.0 by 2231.0. So all of that information is provided to the Intune service, and the Intune service can use that to decide, should I allow enrollment or not? If you've looked at Intune enrollment restrictions, that's where these come from. So you can build enrollment restrictions that can use any of those values to say yes or no. So maybe you want an enrollment restriction that says only version 10.0.22621 or higher. Put that in an enrollment restriction. So at enrollment time, at NPM initialization as part of this enrollment request, it would reject it saying, nope, you don't have the sufficient OS version. But other than that, all you could do is maybe whitelisting of MAC addresses. Maybe you could restrict it to, I only want ENUS languages. So there are limitations to what you can restrict overall, but that's where those enrollment restrictions come from, is that payment. After that, the MDM service will reply back saying, here's your certificate, which will store on the device. You would think it would store that certificate in the TPM for safekeeping. Weirdly, it doesn't, even though the protocol has supported it since it was created. I think Intune's working on doing that. So hopefully in the future it will, but for right now, it's just stored in the registry. So you can find it using the certificate in MMC. So you'll see the certificate payload is a big blob of base64 data. And then there's a whole bunch of other stuff. That other stuff is like an initial policy payload that configures things about the MDM enrollment, as well as some other things that need to be set on the device before a user can log in. Now, so we can see as part of that, there is a set of polling values sent and first sync status. Those are all ESP settings. So the enrollment payload that comes back to the device says, I want you to turn on ESP, and here are the settings that I want you to use. There are also settings here. These polling settings tell it how often to check in with the Intune service. So number of first retries. So there's number of first retries, second retries, and then remaining retries. So it will, you interpret this 5 times, it will check every 3 minutes to see if there are new policies. Then every 15 minutes, it will do 8 more checks. So 8 times 15 minutes apart. And then after that, every 480 minutes, it will check for new policies. So every 8 hours. I think that's 8 hours. 80 divided by 50. Okay. So that's how it figures out how frequently to pull in Intune for new stuff. You could change those. You can push out a custom policy to the machine that says, no, I want this interval for remaining scheduled retries to be 1. And if you set it to 1, it will try to talk to Intune every minute looking for new policies. If you do that on enough devices, you'll probably get a phone call from Microsoft saying, what the heck are you doing? Why are you pounding our service so hard? Intune will reject anything shorter than 3 minutes. So if you do a sync request and then try to do another one 2 minutes later, it will say, nope, fail. After 3 minutes, it'll succeed, but still, they don't want you polling that frequently. The Intune, not Intune, the Windows MDM protocol, and really a lot of MDM protocols have been built initially with that polling mechanism in mind. So the way you get your service to scale is to poll less frequently. So every 8 hours, okay, that's pretty infrequent. It's also not what most IT people want. IT people want to know when their settings have drifted so that they can quickly put it back. Hence, you see, starting with Apple, they started adding declarative configuration capability. So you could say the setting should be this, and locally on the client, it would re-verify that very frequently. Like once a minute, it could re-verify, is that setting still in place? Is it there now? Is it there now? Is it there now? And anytime it diverges, it can set it back. So Apple did it first, and now Windows and Intune have come along and started adding the same thing. So I think you'll see a lot of cases where these become a whole lot less relevant because it's just going to send rules down to the machine and let the machine evaluate those rules rather than checking in with the service all the time saying, my current value is this, what do you want me to do? And then it replies back saying, oh, I want you to change that to that. So it's becoming more intelligent, but the initial NPM protocol was brain dead stupid, where you just send off a request and it does calculation. It sends the whole policy set back down every 8 hours. Not a very good setup. So you can also provide details on additional policy providers that hook into the ESP itself. That's how Intune management extensions work. Autopilot really knows nothing about Win32 apps. That's not part of the MDM stack on Windows. That's provided by a separate service, but you can register a provider that knows how to deal with that. So Intune registers one. If you're using co-management and set up a provision TS and install the config manager client, it sets up another one so that you can track the progress of a task sequence and not complete ESP until the task sequence completes. So there are hooks in there for that. If you weren't using Autopilot, there are policies provided for Passport for Work. Who knows what Passport for Work is called today?
For business.
Hello for Business. Hello for Business. If a user were to sign in before these policies were applied, Hello for Business would be on by default and would always prompt them to enter a PIN. If you wanted to turn that off, a lot of companies do, you have to make sure that that's in the initial payload, the initial policy payload to the device, because there would be no ESP, and therefore the user would sign in before any policies would be received on the device. So there are provisions for getting that onto the device as part of the enrollment process. So after that, the certificate's been received and stored on the device. The initial payload policies have been applied. ESP does its thing. It'll pop up at least, and then it starts monitoring to see what's going on. But behind the scenes, we're just doing sync sessions. So the sync session client will ask the server, do you have anything for me? Server will think for a while, and then it'll send down a policy payload, which is a bunch of requests like this, where it'll say, please replace or add, if it doesn't already exist, a policy called Device Vendor Microsoft DM Client Provider, whatever, expected MSI packages. In this case, with this data, set it. So it's just sending a bunch of these saying, Here's the target, here's the data, here's the target, here's the data, and the client knows how to interpret and process those. In this case, these are ESP settings, tell it what to track. So ESP really doesn't track anything without being told by the MDM service what to track. So Intune is in full control over what ESP is tracking. But every other policy that's sent down is sent in that same way. It's just a SOAP request, an XML blob that says, I want you to set this OMA URI value to this particular constant, and it will take care of that for you. There's some other interesting things going on with hybrid Azure AD join. So as the client syncs with the server and says, do you have anything new with me? It can also send alerts up to the server. And one of those alerts is actually a Bootstrap sync request, which says, I want to do ODJ. So there's this magic request that goes up saying, I'm waiting for an ODJ blob. I want to do an Active Directory domain join. So every time it syncs, every 3 minutes, it sends one of these up to Intune saying, please generate me a blob. I'm waiting for a blob. I'm still waiting for a blob. Still waiting for a blob. Eventually, Intune will get the blob and send it down to the device. And then the device will apply it as policy, which causes the actual domain join to happen. But you do see these alerts being sent as part of a trace that's how Intune knows that, oh, hey, I need to do something in this case. It's listening for those alerts. Now, there's no guarantee that those alerts ever get an answer, which is one of those troubleshooting headaches. If you have a domain join profile that's not targeting the right machines or the right groups, it'll never get an answer, and the machine will just send alert after alert after alert and never gets an ODJ blob, and ESP eventually times out. So that's one of the troubleshooting steps, is to see, sent the alert, but did it ever get a response? If the answer is no, then ODJ is going to fail. Talked about this already. We can skip through that. Pre-provisioning, if we look at what's going on with pre-provisioning behind the scenes, it's just like self-deploying with a different UI. So you hit the Windows key 5 times, it brings up the menu, you choose Autopilot pre-provisioning, great. It doesn't ask for credentials, so it's joining the device to Azure AD, and it goes that way. So it provisions the device just like self-deploying. Hybrid, the implementation for that is kind of like the ultimate developer hack, that there was no simple way to get the device enrolled in Intune using the self-deploying details. Because if you remember, self-deploying doesn't support hybrid Azure AD join, it only supports AAD join. So what actually happens in that case is it does an AAD join in the device and then enrolls the device in Intune, and then it deletes the local AAD join certificate and then lets the ODJ blob received from Intune apply to the device to get joined to Active Directory. So it's temporarily joined to AAD and then joined to Active Directory. So people who are using pre-provisioning with hybrid Azure AD join keep wondering, why are these devices getting enabled in AAD? Device for a minute or so was joined to AAD before it got yanked back out. The other challenge is if you haven't enabled the AAD join process in Azure AD, the hybrid pre-provisioning step will fail because it won't be able to do that AAD join using the machine token, because you haven't turned it on to say that anyone can join a machine to AAD, because you're not using AAD. But there are some gotchas like that, but otherwise it's just a little hacky to first join into AAD, then remove it from AAD, and then join AAD later. So if you look at ESP and what it tracks, it knows how to track MSIs, so line of business MSI app installs. It knows how to track Office 365 and a very small list of policies. And we talked about that earlier, that it doesn't track all policies because a lot of policies fail and that would cause issues. It has the ability for these additional providers to be hooked in. So one of them is Intune management extensions. The other is the config manager task sequence. So those get hooked in. Basically, they just provide additional apps that should be tracked as part of the process. But ESP basically then becomes a simple polling mechanism that checks every minute or so to see the status of those in the registry. Are they completed yet or not? And as long as they're not completed, it continues waiting until they are. So the big question then becomes, well, what does it not track? It doesn't track PowerShell scripts. So if you're deploying PowerShell scripts from Intune, they won't be tracked. The current ordering of things with Intune management extensions, though, that doesn't matter as much because PowerShell scripts run before Win32 apps. But that also means if you push down a whole bunch of PowerShell scripts and they take 5 minutes to complete, you've now delayed all your app installs by 5 minutes while all of those are happening. So you'll just see it spinning and not know what it's doing. Well, it's busy running your PowerShell scripts. It doesn't track any security policies beyond a few that are required to make self-deploying work. So imagine you're deploying, using self-deploying a kiosk, and that kiosk is going to display a web browser. And that web browser should be configured to hide the UI and display a particular URL. Well, by the time the user signs in, because there's always a user signing into the device, whether it's a local user, a domain user, an AAP user. Most kiosks will use a local user. By the time that user signs in, all of those other kiosk-related policies need to be applied, because otherwise you might sign in and there's no auto launch app. So it signs into a desktop. Or you sign in and the browser launches, but it's a full UI. Or you sign in and the browser launches, but it doesn't know what URL to go to, so you get a blank page. All of those mean that you can't log in until all those policies have been received by the device. So for those specific settings, ESP will track them. But for anything else, it won't, as far as policies go. So it's a very short list of things that are actually being tracked. Coming soon, this Autopilot V2 or Autopilot refresh idea. If you dig around inside of the Windows 11 releases and patches, you'll see signs of this, that there are binaries that aren't being used, that there are pages that aren't being displayed. You'll also see references to it inside the Intune management extension logs saying that Autopilot V2 not active. So things are up. We don't know exactly what it's going to look like, but it's safe to say that there will be changes coming to the overall look and feel, as well as potentially changes on the back end or the administrative experience. The hope was this past Ignite that there would be some announcements on that. There weren't. So announcements at Ignite this week, that was a reference to the last time I talked about this, but it never happened. Hopefully it'll happen sometime in 2024, but as of this point, from what I've heard from others, is there's not even any private previews going on yet, so it hasn't yet even reached that point. So might be a while, but certainly there is work going on, and hopefully we'll be able to see the results of that at some point. We're actually going to be on time. So what does Autopilot achieve? Simplifies the movie flow. It gets rid of extra screens, provides additional scenarios. We talked about all those. It can optionally track progress if you via ESP, which may or may not be part of Autopilot, depending on who you ask. Very highly dependent on MDM. So most of the time, if things go wrong, it's not so much that Autopilot went wrong. It's usually MDM went wrong, or AAD went wrong, or TPM attestation went wrong, or MSA went wrong, or something somewhere else in the myriad of systems that are tied together to make this work. Something wasn't working, but as a result, it caused an autopilot failure. So our normal phrase is autopilot's really good at telling you about things that are broken that you might not have known about, but it exposes them. It causes loud failures that will be in your face or in your user space, which generate help desk tickets where otherwise you wouldn't have seen that was going on. That's it. Any other questions? It's really hard to watch the chat while you're going through this because all I see are the little pop-ups at the top of the screen and nothing else. But
Yeah, I don't think we had any outstanding questions. We answered a couple of those that came.
That was really cool to see though. They, especially the beginning stuff, got through the history. I know you're like the resident historian for it, so it's good. Good to have you.
I probably need to do some reading because I haven't used it myself. But where you were talking about staging a JSON file and what if it doesn't find anything, it'll apply that instead. What exactly does that mean? I mean, is this a way to provide some local information so whether you're registered or not, it could actually work?
yeah, so if you have a device that isn't registered with Autopilot and you have a JSON file, it will behave as if it were an Autopilot device, which means the extra screens in movie will disappear. The local admin rights will be properly handled so the users don't get admin rights. It may not get any policies though, because the device was unknown at that point. So unless you had things targeted to all devices, you might see ESP pop up and say 0 of 0 apps, and 0 of 0 certificates, or 0 of 0 network connections. Just because I don't know who you are, so I can't deliver anything to you.
Right.
Otherwise, it's a normal Autopilot deployment at that point. Now, if you had a JSON file and the device was registered with Autopilot, it's going to ignore the JSON file and use the Autopilot profile provided by the Autopilot service instead. So it's kind of like a fallback. If this is behaving like it's not an Autopilot device, use this JSON file to make it behave like it is an Autopilot device. And then Intune can come along after the fact and register it with Autopilot. So if you ever reset or re-imaged it, the next time it will go through the full Autopilot process.
The reason why I'm asking, I don't know if it ties to this at all, is that I've heard of a certain hardware manufacturer that has a challenge with registering and waiting around multiple hours for it to be registered to continue. So not sure if there's something there that can alleviate that.
Yeah, we did some math at one point. So let's say you're an OEM. Dell's a good example. You manufacture a device and you're going to ship it to the organization. You register the device with Autopilot. So you've done your part, you ship the device. You might drop it in FedEx and it shows up at the user's desk the next morning. So it could be 6 hours, 8 hours later. If you got the timing right, you could ship it out at midnight and it could be in the user's hands at 8 a.m. the next morning. The challenge is you register the device with the Autopilot service. When is Intune going to find out that that was done? That could take up to 12 hours because Intune only syncs with the Autopilot service once every 12 hours.
Yeah.
After that sync happens, then it has to go through the profile assignment process, and that could take an hour or two. And it has to update dynamic groups, which could take an hour or two. So our estimate overall was worst case, if everything doesn't work out timing-wise on the Intune and Autopilot side, it could take up to 24 hours before the device is fully ready to be deployed by Autopilot, meaning that profiles assigned, it's showed up in Azure AD, it's in the right groups, Intune knows what policies it's going to deliver to it once it's received. All that's ready to go. Now it's safe to turn the device on. So the request for Dell and other OEMs is after you register the device, don't ship it too quickly because it might not work if all of that stuff hasn't happened. Now, the the goal was for that to be more of a short-term problem, that why is Intune only syncing every 12 hours? Because there was no support for doing a Delta sync.
Yeah.
So Intune could only pull the full list of Autopilot devices, which you really don't want to do on a 200,000 seat, 200,000 device tenant.
Right.
You don't want to do that once an hour. So once every 12 hours is very reasonable. But if you implemented a Delta sync, it doesn't really matter. You could do that much more frequently. If you weren't using a scheduled process, but a triggered process for assigning the autopilot profile, you can make that faster. If you weren't using dynamic groups, or if dynamic groups work faster in Azure AD, you wouldn't need that long of a wait. So the thinking at the time was, well, that 24 hours is eventually going to become something more like 4. And at that point, you're never going to be able to ship a device in less than 4 hours to the end user. So you'll be in good shape. That's just never happened. So 24 hours probably is an overly cautious time frame. It's probably more like 15, because you've got worst case that once every 12 hours sync, followed by the other processes, which could take 2 or 3. But the rounding was to just say, wait a day.
Right.
But yeah, companies like Dell don't like holding a shipment in their warehouse, hold it for shipment for an arbitrary amount of time, because it takes up space.
Right. And I think, I could be wrong, but I think in our pre-provisioning scenario, we can't even wait to ship it. We got to wait till we can actually pre-provision it. So,
Right, as you as the pre-provisioner would have that same problem. If you try to pre-provision it too quickly, it's not yet an AAD, it's not yet an Intune, you may not have a profile assigned to it, it's not going to work.
yeah. So if we have to register it, we power it on to register it. Do you leave it set on the bench for 12 plus hours before you can pre-provision it? Or, you know what I mean? There's a,
Right.
it's killing the lag.
You
Right.
put it aside somewhere in a big pile and
And then
pick it up,
Plug it back in
plug
again.
it back in again. Yeah.
And then when you're providing a service to a customer and you guarantee next day thing, now you're screwed. So,
Right. Yeah, definitely a problem. It's a fixable problem, but I don't think it's been fixed.
Yeah, this comes back to that thing we hear every time we talk to someone on the Intune team, where someone brings up how incredibly slow Intune can be. And it's all about the compute power that they're willing to throw into it on the back end. And so, they could probably fix this, but it would probably cost a lot of money, because then they'd have to bump up the cycles on something to make it go faster.
Or they do it differently. Yeah,
Yeah,
for the policy sync, the way to do it differently is the local policy refresh, which is what they're implementing and rolling out now. I think we just posted yesterday on that, that it can reapply policy locally once a minute, because there is no cloud sync, no network traffic involved. It just stores what the desired state should be on the device so that they can reapply it. In the Autopilot case, it would be much more around Delta processing. There are some Delta capabilities, but they're just not robust enough. Now, the customer could manually initiate a sync to make that faster, but there are restrictions on how fast Intune will allow that. I don't remember what the time frame is. It's 15 minutes or an hour or so. They could set up a scheduled task that would kick that off every hour, which would significantly reduce your amount of time, but it wouldn't reduce it to 0. It would probably reduce it to more like 4.
Yeah.
Which is still too long to leave a machine sitting on a bench.
yeah, in a factory. Yeah.
Yeah.
Build another one faster.
The OEMs that would ship it to a separate location to do that had that easy, because it's like, oh, hey, it's going to take us
Yeah.
a day to get it shipped to the other facility anyway, so we're going to worry about that. But if you're doing the pre-provisioning on the same line, that's problematic.
Okay. Good to know. Good to know. We're doing all we can, I guess, except for having the customer sync. So, all right.
Michael, last one of the question. It's a non-technical, stupid question. So, and a bit of feedback from you. So, how do you like, or what's your reaction? Microsoft's name changing AAD to Entra ID.
I mean, it's not awful.
Question.
I don't mind names, and I spent 16 years at Microsoft, so I know things change names frequently, and you kind of get used to it after a while. But it doesn't mean I'll ever use the new name. It just doesn't roll off the tongue. Now, that said, Entra ID versus, say, Microsoft Fabric.
Yeah.
I at least understand Entra ID and get how it's tied to
Okay.
identity and okay.
Okay.
But every time I hear Microsoft Fabric, it's like, is that like Azure Fabric or are we talking databases? Oh, we're talking databases.
Yeah.
Like, who came up with that name? So there are certainly names that I don't think make sense, but
Yeah.
Entra ID, that's not awful.
Okay. Okay.
I understand the desire to name things under umbrella
Yeah.
products.
Yeah.
Entra as a product category name is not bad.
Okay. It's good feedback. People cannot pronounce Entra. I've seen people talk about Entra, and we have been taught Entra as in Nissan Sentra. So that's how people know it's Entra.
Tomato, tomato.
How many years has Azure been out there and people are still debating Azure versus Azure?
Yeah.
Pronunciation will always be a
Yeah.
problem, but
Yeah. Greg, maybe we can have a 30-minute session as Microsoft name changes. It will be a funny session, I'm sure.
If you want to get some street cred for Microsoft Docs updates, though,
Yeah.
just search, go into Google and do docs.microsoft.com.
Yeah.
And then in quotations, Azure AD.
Yeah.
And you can go do like 200 edits and get all the street cred you want for Docs edits. It's everywhere. Even on Entra AD documents. Entra.
Entra as in Nissan Sentra.
Even on Entra AD documents on Microsoft Docs, it still references Azure AD some places.
yeah, and then there's the inconsistencies are a little more irritating. Like, is it Entra ID join or is it Entra join? Because you'll see both of those in the docs too. And
What about hybrid join?
Entra ID hybrid.
Oh,
It's really weird, but it's okay. I don't mind name changes as long as they're somewhat logical.
yeah.
All right, any more questions? Otherwise, we'll take a little break. All right, thanks, Michael. Appreciate it.